Good morning. Welcome. At almost the last session in the semester. I hope you can hear me. And I hope you didn't have like a trouble to log in, because I think Penn State changed some authentication process. That means I hope we all good. I mean, you are in the classroom, meaning that you are good. You can hear me, right? You can say hi, as always, to the chat box, or you can give me some signal. Yes, because then it's nice. Everybody, come on. Everybody is saying good morning. Then I know that you are here. Yes. Thank you. I hope you have access to your keyboard. Thank you. Thank you. Okay, yes, that means this is the last week of a new material. And then next week we will review for the final. And the final actually will be open, I believe, on Friday or Thursday next week. I have to check the calendar. I'm probably on Friday next week, because we usually opens midterms and finals on Friday, that review week. And if you would like to start reviewing, you can definitely go through exam 1 and exam 2 material, the review questions. They will be extremely helpful. And yeah, we always create the test based on the review problems. That means you can check exam 1 and exam 2, because exam 1 and exam 2, the material will probably cover like 50 or 60% of the test. And the rest of the material will be the new stuff, which we covered after midterm 2. Okay. But let's finish. That means today we will talk about different coordinate system, the polar coordinates. We definitely know the Cartesian coordinates. Everything it's like perpendicular, the distance along the x, along the y-axis, and polar are a little bit different, because when we have complicated curves, or I can say a nice, beautiful, rounded shapes, Cartesian coordinates are not always like the enough tool. Yeah, we need something extra, especially for some round shapes, which unfortunately we will not talk about all of the shapes. Yeah, we have a beautiful flowers we used to cover, but we will not. We will just basically touch the polar coordinates, and I can show you what kind of question we may focus on. Okay, that's me. Let's start. Actually, before we start, I can show you something that I found. Look at this beautiful picture. You probably saw this somewhere. Yeah, it's a Cartesian bear, poor bear. That's what I was saying. Everything, it's like perpendicular. We're just moving we're not moving like a cross. Distance from along the x, distance along the y. But polar curves can describe beautifully the round shape. Yeah. Do you like it? Okay, I think you do. Or maybe the good example will be, I have to do this. I can have the car, like a regular car shape, and did you see the, how do you call, Cybertruck of Tesla? I think it's Tesla. Yeah, maybe it's not Tesla, but it's definitely Cybertruck. Yeah, like a really like square. Yeah, it's Tesla. Okay. Yeah, I think it's like a square. Yeah, it looks like they probably were using Cartesian coordinates. Or maybe I'm saying about this like square size, not the ovals, not the round shapes. Yeah? Looks like a space equipment, space like car. Okay, but yeah, polar bear and Cartesian bear is also a good example. Okay, let me see what we have. Let's start. What we need. Okay, that's mean polar coordinates, we still have a plane and we will not call Cartesian plane, but we may still like see through like the X and the Y axis, but we will have here a little bit different like labels, a little bit different notations. That's what we will have. We definitely need a polar axis. Yeah? I mean, we need the original, like the reference point, the origin. The origin is called pole, and we may picture that it is in the like 0, 0, yeah? Like thinking about the X and Y coordinates, 0, 0. Now we will focus only at the positive part of the x-axis, yeah? The ray, half of the line. I mean, I can say, actually, I can draw for you X and Y plane. Okay, that's actually, I wanted red. And that's the pole, and this is the pole axis. And that's we will, I will not label X, Y, Z. What we will need for the polar coordinates, an angle and the distance from the pole is important. An angle, the notation is exactly the same like from the unit circle, yeah, like from trigonometry. When we will go counterclockwise direction, like this will represent 0 degree, this will be 90, this will be 180, this is 270, and back to 360. And that we can see we're going counterclockwise direction to indicate the angle. If we go clockwise direction, the angle will be negative. That means going actually this way, I can say this is negative pi over 2. Again, I can say this is equivalent to negative pi. This is equivalent to negative 3 pi over 2. And yeah, this could be everything. It's symmetric, but it's equivalent to the negative, like negative 360. That's when we definitely know this, how to indicate the angle. Okay, that's me. For instance, I would like to get the angle, let's say 30 degrees. Is this 30? Pi over 6, pi over 6. Or maybe I can say pi over 6, yeah, positive. Okay, that's when we have to find an angle, the half of the line, the ray that represents the angle. And now from on that ray, we have to indicate how many units we would like to move away from the pole, from the origin. That's mean, let's probably say 1, 2, 3, 4, 5. That means this point will be 5 on pi over 6. That's when we did have the first point, let's say P. And that's when we need number of units. And the same like on the x-axis, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 along the x, y. That's when we need number of like the distance from the pole on the particular angle. And that's the point. That's when we will call the distance radius and angle theta. It's mean the point, in order to plot the points, we need angle and distance. That's it. Yeah, nice and simple. Okay, let's see more details. Okay, that's what I was saying. Point is r, like a distance from the origin, which we call pole. That's the polar axis angle. Okay, now to indicate the angle, we will have two ways: positive notation and negative notation. Also, what happened if r is negative? If r is negative, because if the distance is positive, we will just go like along that angle. But if it's negative, we will count this distance, but on the opposite side. Like we simply have to like turn 180. I mean, for instance, I will even use this one again. Let's picture the angles, and we would like to find out, okay, let's say this is 45. Okay, that's mean this point, 1, 2, 3, 4 on 45. Okay, 4 units, maybe a little bit. Let's say point A, 1 on 45, because then I don't have enough room on the opposite side. Okay, let's say this is 1. I need that point, purple. Yeah, 1. Now, what happened if we would like to find the point B, which the coordinates are -1, 45? Okay, that's one detail. As I said, we will still count one unit, one distance, but the same like on the X and Y, on the opposite side of that angle. That means we will simply make a longer, we will elongate that 45 in the opposite quadrant, but mathematically means that we turn 180. We simply added pi. That means I will add pi. That means on that line, which now, please tell me, the opposite quadrant, all of the angles in the first quadrant, which quadrant is opposite to the first one when we add 180? It's the first one. Okay, thank you, Deepan. Now, if the angle is in the second quadrant, what will be the opposite quadrant? Yeah, like adding 180. For the second quadrant, the fourth quadrant. Okay, that's when you understand. That's when now we have to think, if the distance is negative, then wherever is the angle, like 45 in this situation, we have to plot the point in the opposite quadrant, in the third quadrant. Okay, that's when I will plot the point B here. This is -1, but still 45. Meaning that if, again, R, the distance, is negative, it's never plot in the same quadrant as the angle. So we can say it's the opposite. That means point B is actually here. Okay? Will be 45 plus 180, 225. Okay? 5 times pi over 4, but no, if it's -1, that means we have to say pi over 4. Okay? That's when we know the negative notation for the angle, and we know negative notation for the points. Now we can plot any point. Let's see. Okay, that means this is the angles, positive, negative. We knew that from the trigonometry. Okay, now this is the notation for the negative. Yes, negative distance. Okay. I mean, now what we probably realize, since we have so many like interpretations, so many labels, so many coordinates, like positive, negative, one point in the polar plane could have infinitely many representations. Do you think? Let's just say, let's even use, okay. We can use that plane. Because for instance, let's put some angles. We can still say this is 45. Okay, and let's say that distance is maybe 2. Whatever labels is fine. That means this is 1, this is 2. That means this point is 2 pi over 4. Okay, and that's the point. We know that in the Cartesian plane, when we have one point, I will put the dot, it's only one unique coordinate, like the coordinates representation. Yeah? If I will say like 5, -5, it's only one point. No other like coordinates will represent the same point. In polar, we may have infinitely many. That's now you can try to give me. This is definite positive distance, positive angle. Let's focus on that point. We can call it A. And then we will focus on the other. Okay, if I will say 2, the distance is 2, what will be the negative representation of pi over 4 using the negative? That means instead of using that angle, I would like you to tell me what is that angle, purple. What is this angle going clockwise direction? What is the purple angle? Is the same angle? We can see it's -3 or more. 1, 2, 3, 4, 5, 6, 7. Yes, -7 pi over 4. We will get back. Yes, -7 pi over 4. And we remember that's how we can indicate. That means this angle, that terminal side can have the representation of as a pi over 4 or negative 7 pi over 4. And we can actually still adding, yes. Oh yeah, that's Rishabh, that's really good because you can add, you can basically add 2 pi, 2 pi, 2 pi, or subtract 2 pi, 4 pi, 6 pi. Every 2 pi, the situation repeats. We have to just, yeah. But just saying, like we will not go above 4 pi, pi over 4 and negative 7 pi over 4. Okay, that means now, if I would like, let's see if you can help me. I would like to indicate still the same point, A. I would like to use negative. Let's see if we can think. Negative like notation for R. Since I'm saying negative 2, okay, then that angle, that question mark, and we can get 2 of those. Okay, that question mark, that angle supposed to be in the opposite quadrant. That means what angle will fit? Yes, what angle will fit? Still plotting that big red dot, point A, but have negative 2. We have to be on the opposite. That's we will really good, depend. No, negative. Oh, I'm sorry. Oh, yeah. Not 3. Correct. We need that angle. What is this angle? What is this angle, the red? This one is 5 pi over 4 if I use the counterclockwise direction. Yeah, basically adding 180, adding pi. And now, when I will put 5 pi, correct? 5 pi over 4, that's the third quadrant, but I see negative 2, then I have to be to the opposite. It will be point A. This is A, this is A. Okay, and can you give me negative? Still negative 2. Still, I want to plot the point in the first quadrant, but I also want to have negative angle. Who can give me correct negative notation for the angle, but still will be the point A? We just need, yes, that's really good, because we will need, what color, maybe green, we will need that angle, that green one. And the green one is negative 3 pi over 4. That's, we have negative 3 pi over 4, okay, that's the angle. But I see negative, I will plotting negative 2. I will be plotting the point in the first opposite quadrant to the third one. Okay, that's, you can see all of these points, all of these coordinates, actually not points, because it's all of these coordinates represent 1 point. And that's, this is unique thing about the polar coordinates, which actually is not unique representation, because unique representation we can only have in the Cartesian plane. Okay, and that's, please make sure that we know how to plot the points. Okay, and let's maybe plot these points as a quick practice. Okay, the first one, A, 1, 5 pi over 4. You can see I'm drawing this, I'm not really labeling X and Y, yes, but it's just like a trigonometry. Okay, 5 pi over 4 will be that angle, correct? 5 pi over 4, that's the angle, and distance 1, let's say this is 1, A, correct? Okay, now B. I'm trying to squeeze. Where will be the B point? Let me maybe find a spot. Okay, 3 pi. Where is the angle 3 pi? Oh, that's actually, we said this is 0, this is pi over 2. Yeah, we're supposed to label this. Okay, 3 pi, right? 3 pi is like 2 pi and 1 pi. That means this is 3 pi, that angle. And distance 2, 1, 2. 1, 2. That means this point is B. Okay, 2, 3 pi. And you can see it's not negative 1 and 2. Yeah, it's distance 2 on the 3 pi. Okay, what about C? In which quadrant will be the point C plotted? Okay, negative 2 pi over 3. It's negative 120. That means it's that angle. Negative 2 pi over 3. Correct, that's the angle. That's 0, that's 90, 180, and so on. Okay, and now 2, 1, 2. That's the point C. Okay, I have this tendency, but I'm not labeling X and Y. Pi, 3 pi over 2 and 2 pi. We know the notation. Okay, 3 pi over 4. Okay, everybody will tell me in which quadrant we will plot point D. In which quadrant we will plot the point D? Deepen is saying 4. Yes, everybody agree? Let's see. 3 pi over 4 is that angle, right? This is the angle. 3 pi over 4. But now it's negative 3. Then I 1, 2, 3. No, I have to be in the opposite quadrant. And 1, 2, 3. That means this is point D. Okay, it's negative 3 and 3 times 45. Yes, second, thank you. Oh, I mean, no. I'm just reading from the chat box. 4. This is the point, 4th quadrant, because it has to be in the opposite quadrant than the angle is provided, because it's negative radius, negative distance. Okay, you can rewatch this, you can try to practice. Okay, now, what is important? Oh, yes, I have this solution. We know this, yeah? Each point has many representations. What we will try to do, we will actually try to be like flexible, converting from Cartesian to polar, from polar to Cartesian, especially the points. The entire curve are sometimes not possible. We may still get some basic equations, like some maybe circle or line. We may have the Cartesian representation, which we all know, and we can have equivalent polar coordinates representation. But let's start with the points, right? Okay, this is just the same thing. You may practice this one. Point A, point B, and point C and D are all the same. You can see lots of different coordinates. I mean, lots of different representation, but it's on its point in the 3rd quadrant, the blue dot. You may practice this. Yeah, make sure that you know how to plot the point. Okay, now I would like to make some connection, as I said, between XY and R theta. And what I did, I plot everything in one plane. You can see X and Y, and you can see R and theta. That means this point, the red point is. And now what I would like from my students to use your previous knowledge from algebra, pre-calculus, calculus, and get some connections, some equations, which will connect R theta and X and Y. Any equation that you will think are good. We need 4 of them. And that's really important. Yes, really important. It will be helpful later for, okay, 4 equations. Any, we see the angle, we see the right triangle, we see X, Y, R. We may get connections through some previous theorems and definitions and formulas. Okay, at least one. Yes, yeah, that's actually good one. Tangent theta, yeah, is y over x. That means when we will have y and x, the Cartesian coordinates, we can get tangent theta. If we have tangent theta, we can get theta, not a problem. Yes, and okay, Scott, but I will write, yes, Pythagorean. That means let me actually, x squared plus y squared equals to r squared. Yes, square root, but then we have to put plus or minus r. Yeah, but when we will keep this way, then we can figure out later because we know R could be positive or negative. But yes, Pythagorean identity. That means that's actually, these two are really good when we have X and Y and we can get R and theta. Perfect. Okay, we need another two. How we can get X and Y if we have R and theta. That's, we need these two equations. Probably some trigonometric ratio. Yes, because let me write on the side. Sine theta is Y over R. Then Y will be R sine theta. And yes, and cosine theta is X over R. Then X is R cosine theta. Okay, that's it. We need these four equations to like convert. And now converting, if you have, which way? If the R and theta is given, then probably getting X and Y will be not a problem. But when X and Y is given, we have to be careful to get R and theta because of these negatives, and some trigonometric equations. But either way, we will use these equations. That means these are important for this section, really important equations. Okay, it's me now, I have them. I type them. R cosine theta, R sine theta, which is the same like unit circle. But unit circle means the radius is 1. X is always represented by cosine of the angle, and Y coordinate is represented by sine theta. Everything is connected in mathematics. Okay, now let's see. Very basic question. Let's convert 2 pi over 3 from polar to Cartesian. The smart thing is to actually plot the point, thinking where we are, in which quadrant. Then we never make, like, even if we make arithmetic mistakes, we can always correct it. I mean, I can plot this. Pi over 3 is actually 60 degrees, right? Yes, of course. We can just get, let me put X and Y since we will. That means this will be 2, right? 1, 2. This is the point. We need Y and we need X. The point at the moment is 2 pi over 3, but we will need X and Y. X and Y. And we can say this. Okay, that means X is R cosine, Y is R sine theta. I can even connect them. 2, because this is R, this is theta. Cosine and 2 sine of 60. Okay, what is cosine? Yes, cosine of 60. I'm just, cosine of 60 is 1/2, and sine of 60 degrees, I see. Okay, 1 square root of 3. 1 square root of 3. Everything makes sense. 1 and square root of 3 is bigger, longer than 1. Yeah, perfect. That means 1 square root of 3 represents 2 pi over 3. Nice. But we can see the output that we were looking for is only one. One chord, like one representation, one coordinates, like set, pair. Right? Now let's see this way. Yeah, I have the solution for my students. Okay, now represents the point with Cartesian coordinates, 1, -1, in terms of the polar. And here, theoretically, everybody can give me different answer and the answer will be correct. Because everybody can go like at 2 pi, 2 pi, 2 pi. Okay, where we are, that's important. Which quadrant? Which quadrant we are? 1, -1. And this is the point. Okay, A, 1, -1. But we will need the Cartesian. We will need the polar coordinates. Okay, that's mean for the polar, we need this. We need that, this. Oh, my writing is, oh no, 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 no. Okay, we need that distance, r, and we need the angle. Now depends. Let me just say that's r. Maybe this angle, maybe this one. Maybe negative notation, maybe positive notation. Okay, but what formula we will use? R squared equals to x squared plus y squared. R squared equals to 1 squared. Of course, that's silly, you know, 1 plus 1, 2. Okay, that means R could be positive or negative square root of 2. Let me actually say, we may have positive square root of 2, positive square root of 2, let's get 4 of them, negative square root of 2, and negative square root of 2, because that's the standard 2 forms. I mean standard, no, 4 representation. Okay, that means positive or negative. If we're using positive, we need the angle from the 4th quadrant. Can you, oh, actually, we need an angle. We will need tangent. Y over X. Yes, that's correct. That means I use this equation and I use this equation. Okay, that means tangent theta. It's negative 1 over 1, it's negative 1. Please tell me, I know that we can use arctangent like Scott gave us, but tangent for what angle is 1? Or tangent for what angle is negative 1, respectively? Do we know the angle? Because yes, that means this is pi over 4. However, negative will give us negative. Or I can say, what's the positive notation for negative pi over 4? 7. 7 pi over 4. Okay. That means since I will use positive square root of 2, positive distance, I can say 7 pi over 4 or negative pi over 4. That's the 4th quadrant. Yeah? I mean, all of them will be in the 4th quadrant. That's maybe, I was thinking about the angle. Okay, but now, what angle we supposed to use if I would like to use negative radius, but I still want to plot the point in the 4th quadrant? That's what angle we will use. Yeah, we will use the angle from the opposite quadrant, just adding pi. That's what is this green angle? We can have this notation, or we may have the negative. Yes, the green one, yeah, this will be, thank you, 3 pi over 4. Or what about the negative notation for the green? This is 3 pi over 4, or is equivalent to 5? Negative 5 pi over 4, going clockwise direction. Okay. That means these are the angles from the 2nd quadrant, but since I have negative radius, I will plot them in the opposite. That means we may have 3 pi over 4 or negative 5 pi over 4. So nice. Okay. Yeah, that's me. And I can still add 2 pi, 2 pi, 2 pi, or subtract 2 pi to any of these angles. But they are like standard, yes, standard, keeping the domain between negative 2 pi and positive 2 pi. Yeah, but we can, and that's still the same point. That means this is, yeah, the representation. Yeah. You can give me one of them, you can give me all of them, depends, yeah, depends what you prefer. Or just, yeah, just the one, even different. Okay. Yeah, that's mean this way is, we have to be just careful with the angles. One thing, because we know, like, everybody is confident with 3 pi over 4 and negative 5 pi over 4. Yeah, just, I would like just to know, we okay? How I got 3 pi over 4? Okay, just yet. And it's just on the opposite side. Or we can basically add pi. Yes, we can just basically add or subtract pi. Oh yeah, because when this one, when I will add pi, it will be 3 pi over 4. Yeah, that's what we got. This one. 7 pi over 4, we have to be careful how we can get 7 pi. Yeah, but 7 pi is, no, 7 pi. Then we have to, what happened when we add, when I add pi, it will be, or we can, I'm just thinking, okay, I will not confuse you. You know how to do this. Definitely we adding pi. I just don't want to, because when we will subtract 2 pi, then will be negative pi over 4. Okay, you can definitely, it's too many representation, but in general, we will add pi. Yes, we will add pi and then we will get the opposite quadrant. That's the most general. We can still figure out. But 7 pi, I'm just checking, it is correct because it's the positive part. Yes. Correct. Yeah. Okay. I'm just getting, yes, confused because when I subtract, I know what is happening. When I subtract pi, which I can also do this, I will still get this one. It's okay. And then when we have the positive representation, then we can always get the negative representation. Okay, good. Let's keep moving because we have one more exercise. Yes, that's, I just typed like the positive radii. Okay, it's mean now what we need. Yeah, the correct quadrant we can represent. That's okay. That's the equations, but I need one more, but because what we will need, as I said, we will not go really deep in some polar curves. We know how to plot the points. Now, I just would like my students to plot the basic curves, and the basic we will call a circle and a line, okay? And then we have to know the equation. And let's see. Polar graphs like the same, like when we have y equals to f of x. Yeah, that's the polar, like the function. I mean that's the Cartesian coordinates x, y. That's almost the same we will do for the polar. R equals to f of theta, or theta equals to f of r, but usually is radius in terms of theta. Okay? Or like the general form function, which is x, y, usually for the two variables, depends. Okay? We may also have a constant that only information about the r are provided or about the theta. That's me. Let's start. For instance, this one. Oh, and this is the proper polar plane, polar like, which I can still write 0 and 90, 0, 90, 180, 270. Okay. What curve is represented by the polar equation just r equals to 2? Yeah. No information about theta. Theta could be any angle from 0 to 360, 2 pi. And we have to just indicate the distance 2 from the pole. What do you think? What your imagination is? What do you visualize? What do you imagine? Radius 2. For 0, let's say this is 2. For 0 degree is 2. For 1 degree is 2. For 3 degree, 4, 4, 5, 6, 7, 8, 9. For 90 degree is 2. 91, 92, 93, 180 is 2. 2, 2, 2, 2, 2, 2 for all of them. 270. 2, 2, 2. That means what shape? What shape we will create? If I will plot for every single angle, then I can connect these points. It doesn't really matter the angle. This will be basically a circle. Oh, come on, you can tell me, you know. Okay, now extra exercise. What is the Cartesian equation for that circle? This is polar equation, r equals to 2. Yes, because we have one of the 4 equations. Yeah, you can write it down. It's x squared plus y squared equals to r squared. Then x squared plus y squared equals to 4, because r is 2. And we know that this is the circle with the center 0, 0, and radius 2. That means these are equivalent. Okay, that we know the circle. And this is simple circle. We may also move the center of the circle, and then equation is a little bit different, yes, but we will not do this one. Just the circle with the center 0, 0. And this will be basically the equation r equals to a, any constant. Yeah, r equals to, then the center is, of course, the distance is 2 from the pole, from the center. Okay, that means any equation like this is the circle. Okay, simple. Now, another equation. What is this one? Sketch the polar curve, theta equals to 1. I will put this because I like to have this. Okay, one thing maybe it's a little bit confusing because theta is usually in the radians. That means this is 1 radian. And we usually use the pi notation. That's mean, do you know how many degrees is 1 radian? Like approximately? Yeah, you remember from trigonometry? It's, I mean, we don't, oh yeah, this will be the equation, but I'm just saying how to like know what is the angle. No, 180, no, 180 is 180, let's do this one. I can give you the hint. 180 is pi. And pi approximately, because pi is the number, it's 3 point, like it's 3. And we're looking for 1. We're looking for 1. That means what will be the good representation in pi? Yeah, pi, but let's say pi is 3. Pi over 180, no, pi is 3. 3 over 180 is not 1. Something that will give you 1. Yeah, let's say 3. Then will be easy. Yes, pi over 3, because 3 over 3 is 1. Thank you. That's what okay, that's we can actually say that this is approximately 1 pi over 3. Approximately 1 radian is 60 degrees. Good. Yeah, that's good. That's when you see 1, it's like we don't know, but yeah, it's 60 degrees. Okay, we have that part. We still don't know what is the polar curve. Okay, that's mean now no information about the radius, the distance, could be anything, but the angle must be 60 degrees. So let me draw this, and radius could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we will create, what shape we will create? We will create basically a line. But if the radii are negative, if the distance is negative, I think we will add pi and we will have, yeah, because if they are negative, I will plot them in the opposite quadrant. That means it's just the line. It's basically a line. And now let's also add me additional exercise. Let's find the Cartesian coordinate, Cartesian representation of that line. Yeah, one of the 4 equations, and I think I saw it, somebody, tangent theta is y over x. We know the angle. What is tangent of pi over 3? Tangent of 60 degrees. Who can tell me tangent of 60? We know square root of 3. Yes, thank you. And now I can just solve it. Square root of 3x. The slope, of course, the slope is the tangent. square root of 3 of x. That's the line. Or we can say theta is pi over 3. I mean, this is the equation, polar and Cartesian. Okay, that's we need to know lines and the circle. Okay, because I have another 2 exercise. Yes, it's just a line. Okay, let's try this one, because this will be kind of like the question that you probably saw on your, I mean, you will see this week. Sketch the region bounded by, and that's the Cartesian, x squared plus y squared equals to 9, x squared plus y squared equals to 81, and then y greater than x, meaning that we have to draw a line y equals to x and everything above, and y greater than negative x. We have to draw the line y equals to negative x and everything above. And now we will sketch the region, and we have to provide the inequalities, but polar domain, polar inequalities for the region. Let's see what I mean. First of all, let's draw it. What's the first shape? The first equation represents what? Who can tell me? Easy, that's Cartesian, right? It's the circle with the center 0, 0 and radius 3. I mean, maybe I can draw a circle. This is 3, okay? What about 81? What is the radius for 81? 9, okay. Let's pretend this is 9. This will be 9. Let's say negative, but I will not put it on this side, because if it's polar, I will not put negative. If it's Cartesian, I will put negative. Okay, 3 and 9. Okay, that's a region bounded by these circles. That means I'm assuming it's definitely between them, because to be bounded by 2 curves, for now, yes, for now, this is the region. We still have to restrict. Oh, actually, maybe we can, since this is definitely that region, what will be the radius between what values? If we have the region bounded by the circle like 3, radius 3, and less than radius 9. That's what are the, that's what we want. The radii are between greater than 3 and less than 9, correct? Do you see the green region? Okay, good. Now let's draw the line y equals to x. Line y equals to x is basically that line with the slope 1. But we need everything above, because y must be greater than x. It means everything above is this one, correct? But when what intersects, that part intersects, yeah? Because everything above the line, but inside that washer. Yeah, we know the washer. Okay, and we have also another line, y equals to negative x. And also y has to be greater than that line, above. I mean, above means this. Above the line. And then where is the intersection? Here. Correct. This will cover. Okay, I think we got above one line, above another line, and between the circles. That's the blue region. And now we have to give this polar representation. Radii are actually between 3 and 9. What about theta? That's the angle. We have to find out this one and this one. Because the angle is between this, the region, yes, is between that angle and the other angle. Theta 1, theta 2. Okay. Do we know? How can we find the theta? What is the angle? This is definitely the line y equals to x. This one is y equals to negative x. Then when we use tangent, again, one of these 4 equations, it's y over x. Yeah? And then if y is x, we will have x over x, which is 1. Then tangent for what angle is 1? Tangent for what angle is 1? And we know we are in the first quadrant, then we can use pi over 4. We don't have to say the other one because we can just say this. Because we are in the first quadrant, okay? That means that angle is like pi over 4. It means theta is between pi over 4 and what will be that angle in the second quadrant? Oh, come on, help me. Is negative x over x. Tangent theta is negative 1, yes. Then it will be second quadrant, 3 pi over 4. 3 pi over 4. That means this is the answer. That's the polar inequalities, yeah, the restrictions for r and theta for the described region. Okay. Okay, now I have another one, but you can practice. Please tell me this, what I can do. This is 3 questions, but I would like you to give me, the angles are 45, but maybe who can give me that description? Let's say I would like to get the inequalities for that red part. Okay, this is 45. And what are the radii? 3 and 5. Okay, that's please give me the restriction for radius and for theta. Okay, radius, yeah, just part C, and I even create different region. Radius is yes, radius is relatively easy. However, we have to still pay attention. And theta is between pi, correct? And did you say 5 depend? 5 is correct. 5 pi over 4. Perfect. Do we know that? Okay. Please, yeah, please pay attention. And we always start 5. We always starting from the lower angle to the bigger. Yeah, that's the inequality. I mean, we have to respect the inequalities. Okay. Nice exercise, nice easy points on your test. Okay, and one more exercise today. Oh yeah, I have solution. Something like this. Okay, we will, as I said, we will not plot these complicated curves because you can see that curve. Yeah, the polar curve is r equals to tangent theta secant theta. Yeah, we will not know. We just have to know the equation of the circle and the line. But we're not plotting, but we may, and actually we are able to convert from that polar equation to the Cartesian. Okay, that's in which equation, which Cartesian equations, A, B, C, D, or E represents this one. R, we have to convert tangent theta, secant theta. Okay, tangent theta, secant theta. We have to remove all of the r's, all of the thetas, and have x and y. Okay, we remember 4 equations will help us. X equals to r cosine. Y is r sine. Tangent theta is y over x, and x squared plus y squared equals to r squared. Yeah? On the test, I will recommend like to write them down. Then you can see. Okay, I will keep r for a second. Tangent theta, what we can put, how we can replace tangent theta? Yes, actually y over x, it's fine, it's fine. Okay, what about secant? We know cosine theta is x over r, then I can flip it. It's 1 over cosine. I can say r over x. And now I can divide both sides by r. It will be gone, and we're done. 1 equals to y over x squared. Y is x squared. Is basically the parabola. Yes, am I right? Yes, it's not 1 over x. Oh, we have to be careful. Yes, it's y equals to x squared, not 1 over. Yeah, it's just the parabola. How funny equations, tangent theta, secant theta. Okay, that's it. Please make sure that you know this. Maybe one more. Let me check. Oh, this is the. Oh, okay. This is, I think, because I was solving. This is the one of the achieve question. Actually, it's the Cartesian equation, and you may check this later, and we end up with the polar equation because I don't have this, but let's maybe solve this one, and this will be our last question, okay? Then you are master with polar coordinates. Nice session, yeah? Lots of details, but nice session. Okay, let's do this one, r squared. The problem is sine 2 theta. We will need that because the 4 equations that we have are not double angle, it's a single theta. We need the formula for the double angle for sine. Oh, depend, okay, wait. What's the formula for sine of 2 theta? 2 sine theta, cosine theta, really good. Okay, so now let's start. I will copy r squared for a second, 2. Actually, we can divide by 2. Then that 2 is gone. I can put 1. Okay, sine theta is y over r. Cosine theta is x over r. And this is 2. Now we have r squared, xy r squared. We can simplify this. It's 1. We done. We did eliminate. That means y equals to 2 over x. And I think, Deepan, you're right. It is. Oh, no, yes, it's the option E. Okay. With r, we have to be, I know that if you see r squared, yeah, you can definitely put x squared plus y squared. But sometimes it's nice to wait. Yeah, you can see what I did. Maybe the r will be canceled like itself, and it usually does. Like this one was r, yeah? Then we avoiding to put the square root because again, the r cancel out. And I don't have actually, I don't know why, I don't have the other way, but you can check this, yeah? Don't look at the solution. Don't look at the solution and try to convert that Cartesian to polar, okay? As an exercise. I will remove this because this is correct. Don't look at the solution, okay? Okay, thank you very much. And tomorrow you will have just additional one like formula, which is a little bit related to the, imagine like the complex numbers and the polar coordinates, Euler formulas, easy. And one like way to solving differential equations using the power series, okay? And that's it, really short session, really short like material. And next week we will try to wrap up. Please attend the review session next week. Yeah? I will try to give you helpful information. Okay. And no, not end of this week. We still have next week for the review, end of the following week, not this week. Yeah. Yeah, next, because this is still, will that be the final exam? I don't understand. Oh, check the calendar. Check the class calendar, okay? Check the class calendar, everything is there. Because it's so many information. No curve, yes, no curve on the exams. That's how the math department is, yeah. No curve on the midterms or the final, okay. Yeah, please check in the getting started module, the third link, I believe, is the class calendar. You will have, yes, you will have all of the dates. You probably know it's end of the semester. That's, you know, all of the dates. Oh, I don't know how many questions, like, yeah, similar to the midterms, a little bit longer maybe, because we have a little bit more time. Yeah, we will have probably 20 minutes extra. 20? I believe it's 20 minutes extra. Okay, that's me not a little bit longer, but it's, I will really suggest working on the exam 1 and 2. I mean the material, yeah, because it will be so helpful. And we will just, yeah, and even reviewing your exam 1 and 2. Oh yeah, all multiple choice, no open-ended. Multiple choice or drop down, like as soon as you submit, you're supposed to have your results. Yeah. Okay. Thank you. And yes, keep reviewing. Thank you and see you next week. Big review session. Thank you.